You can attend the Zoom meeting using the same connection. How about now? Is there any shared screen? Okay, yes, it is okay. Okay, you can use that notation for this example. We wrote like that as a true, true, and true, false, false, true, false, false. Instead of true, we can write 1. Instead of false, we can use as a 0. So according to that, you know, changing 1, 1, 1, 0, 0, 1, and 0, 0. So we will use again not Q. For not Q, 1 instead of 1. Here is gonna be 0. I can see the, you know, microphone waving signal on the UBIS. From my side, there is no problem for the voice or speech. But you know, Saturday and after, you know, 7, there is really a problem from the internet connection. And for Q and Q hat, Q prime, not Q, you can write here as a 0, 1, 0, 1. So for the AND operation, you write here to make it soft or something. And AND operation, right? Okay, 1 times 0, 0. Something is wrong because I got here as a true. P and not Q, 1, 0, 1, 0, 0, 1, 0, 0. Yeah, 1 and 1. I will have here as a 1. Okay, 0, 0. I have here as a 0. And 0, 1, 0. So both are same for my side. And you can use this way also. And next what we have, is there any chance to make it like, yeah, can make some change on screen. Okay, I'm really happy. Anyway, I'm trying to learn also how can I use that interface to explain better way to lecture. And there is the new definition as a tautology. And contradictions. So we write, you know, some in previous title, some propositions like P. Inside of the P there is the small letter P, Q, R, S. so on, contain only true in the list, I'm sorry, in the last column of their truth table, or they are true for any truth table, truth value of their variables. These kind of propositions are called tautologies. So let's write example. 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 Okay, let's write here as a P and Q, and there is the R. Okay, let's say 3 value as a statement and 3 variable. So we will have something to right side and true, 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 false, true, false, true, true, false, false, true, false, false, and false, true, true. We need some more place. And false, true, false, 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 true, and false, 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 and false, and false. So we can separate here as a 4, 4. So we want to something as some propositions should be true. So we have true here, and here is also, you know, false and trues. Okay, let's write Q or not R, not R, like that. So let's find that one. Okay, Q and not R. True, true, true. One of them true. It's gonna be true, true, and true, and true, false, true. This is gonna be true also, and again true, true, false, false, and here is a false. I'm sorry, we didn't get the one. and here is the true. And then we have all is true just here as a false, right? To make something is different, then get here as a not P and Q. Sorry, okay, that's correct here. And Q and not R. So we will have here all is true, right? Because not P here is gonna be false, 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 and true, 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 true. Then I will change here as a true. What do you mean, Batuan? And here, third one. Yeah, here is also true. I'm sorry, false. Okay, let's check again. False. Yeah. Okay, here is the false. Right? What one? True, true, false, true, 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 false, true. So I have to correct here also. So this is not enough. P is not enough. And false, true, false, true, false, true. So I can do like that. This is the better. If I write here as a R, then here is R. I will have here as a true, 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 and true. Is that correct? R, true, true, false, true, true, false, false, true, 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 false, true, true, false, false, true. Then I will get that one. So this is the tautology. And there is also inverse of that one. Inverse of that one also. Okay, let's write analogously a proposition. Again, P, there's the P, Q, let's say RS, is called contradiction if, so there is a condition, if if it contains only false in the last column of its truth table, So this is gonna be a contradiction if we have as a last column result false, reverse of that table, we will say this is the what? Contradiction, right? Okay, can we take all this? Okay, is there any way? Okay, let's try to copy here. Yes. And let's change the last. Okay, we have different solution. Okay, example. So we want to do last, and here is the truth, right? Not R and truth. So, and false, false. If we put here as a what? True, true, not P is gonna be reverse, is not working. And true, true, false, false. I want to make here as a, you know, all false. So change that one also. Q and R. It's going to help something. Okay, true, 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 false, 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 and true, false, false, and false. Okay, now I have that one. Q, and here is the truth, and truth, make it something is reverse. Yeah, actually we are looking for to change you know, last column of that truth table as a false. You know, first one as a tautology, all was the truth, and that one is a contradiction. You know, whole last column should be false. Yeah, I accept your, you know, suggestion, Emre. You can use as a Q and Q prime as a not Q, but I'm using the same notation of your book. But if you use that one, what you wrote in the chat, I'll accept it. Okay, don't worry. Okay. Okay, here we have true, true. I want to make that true as a false. Okay, not Q, and okay, let's try not Q and Q and R will give me as a all false, right? Not Q, false, true, false, 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 true, false, false, true, false, false, not Q, false, 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 true, false, and false, F, 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 and F, a true, TF, true, false, and false, true, false, and false. So this is the contradiction as an example. And what else? And logical equivalence as a new title. Logical equivalence. How about connection? Can you follow the lecture properly or some problem? You can follow. And here is the some students also in Zoom. And Emre and Metan. Okay. And let's write definition. Two propositions like P and Q, and inside of the P there is the PQ and something more, and there is the Q also as a combine some PQ and so on. Propositions are said to be logically equivalent or simply equivalent, right? It could be. There is some chance then we will say these are equivalent or equal, and we will denote like P and P, Q, R, S, so on, equal to Q propositions. Again, there is the maybe P, Q, R, S. There's some sub propositions. Maybe they are equal to each other according to some theorem or some algebraic manipulation, and maybe they have equal directly to each other. So as an example, okay, let's write the example. Example, it is the really best way to explain some idea. Okay, we have P and Q are famous propositions, and they have, you know, same true, 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 false, and false, true, and false, false. And P and Q will have the truth table like T, F, F, and F, and not P and Q, reverse or inverse of that column as a false, true, true, and true. So we will write, okay, let's write again P and Q, basically some kind of proof. Here is the true, 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 false, false, true, and false, false. So let's write the not P and not Q. Then I will write not P or not Q, not P or not Q. Okay, let's write here as a not P as a false, false, true, true, and not Q, false, true, false, true. So our operation for that two propositional statement, false, false is going to be false. False, true is going to be true. True, false, true. And true, true is true. So when we look at that two propositions, inside of that propositions, there is the P and Q sub-propositions. Batuhan? P and Q, true, false, false, true, and false, false. So what do you mean? False, false, true, true, not Q, false, true, false, true. There's no, mistake. You see that two propositions are equal, right? False, false, true, 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 and true, true. So it is working. That one, you mean? I didn't get what you mean, that one. Okay, so it means not P and Q in parentheses equal, not P or not Q without parentheses. So we found that equalities, this is kind of truth table proof actually. And let's continue what we have. Algebra of propositions, actually this is, algebra of binary system, right? Boolean algebra. Algebra of propositions. Okay, this is known in logic as a Boolean algebra. And we know that one from the logic in hardware of computer science. But we will talk about, proposition side. Okay, let's write is there any way, okay, I'm gonna do something faster to write that table. If it is the way, I will copy it. Yeah, I can do that. Okay, now we are really fast to write that table, and we can talk about the table, what we have. First one, we will talking about the what? Equalities, right? So algebraic equalities will help us as a, base of the proposition, like the P and P is equal P, right? P and P is equal P. I'm sorry, P or P is equal P. Okay, and P and P is equal P. We accept that one. Also, we agree that as a conjunction and disjunction. Batuhan, Emre, you agree that, right? If you take the parentheses as a, associative law, also I will, submit that note converting to PDF. I will submit that lecture note to you, okay? And we have associative laws as a P or Q in parentheses or R is equal. First you take the Q or R, then you will do operation with the or operation with the P. Here is the equalities. We will accept that one. Also, it is working for associative law for the AND operation. P and Q in parentheses, then and R is equal Q and R, then AND operation with the P will be equalities for that too. And P and Q is equal Q and P. There is the commutative laws, and you can say duality, and you can change the place of that proposition. This is working for the OR operation, also AND operation. There is a duality or commutative laws is working in that algebraic calculation or manipulation, whatever you want to say. Emre is writing. So, do you have any question? Which one, Emre? Okay, I'm coming. Don't worry. Don't be hurry. I'm coming there. Okay, Emre. So distributive laws, there is the, this is not working our regular algebra. Let's see here, P or in parentheses Q and R equal. You can separate that one as a P or Q and P or R. You can separate like that. This is the distributive law. It is working. This is not working in regular algebra or 10 base calculation. So here is also reverse of that one, P and in parentheses Q or R. You can say P and Q. You are making the distribution P and Q or P and R. This is also working in that manipulation or calculation. If you say P or false, it is going to be P. For Emre, this is P plus 0 is equal P, right? This is for Emre. And this is also for Emre. P times 1 as an AND operation is equal P. And here is the P plus 1 is equal 1. And here is the P times 0 is equal 0. So 2 times reverse of P is equal to P. You can say P prime in parentheses prime is going to be equal P. You accept that one. And how about here? Okay, you said no for that one. Okay, let's check. it is correct or not. P or not P is equal true, right? So it is the P is 1. Let's say for one of them, 1 plus 0 is equal 1. Yeah, this is correct. It is working. And how about that one? One of them will be 1, other one is going to be 0. 1 times 0 is equal 0. So not true. You mean that one, am I right? Book is giving something as a wrong. Yeah, let's correct here. As a false, okay. Is there any way? Make it like that. No, I can change the T. Okay, change the pen as a black. Okay, this is the false. So we got the point for Emre. Okay, let's continue. Okay, inverse of the true is false, inverse of false is true. So how about De Morgan? De Morgan is correct, Emre? Did you check that one? Yeah, this is correct. It is working. How about that one? This is also correct. Any question? I think we did something is really fast than other way. And okay, let's write conditional and the conditional statement. Conditional. Any question? Just a second. Here is the problem. Connection. Emma, do you have any problem or question?
By conditional.
Okay. I hope we can write the title. Yes. Conditional and biconditional statements. What we have for that one. Okay, there is a definition. Many statements particularly in mathematics. mathematics are often